Hello viewers! Last time, we discovered how the second derivative test can instantly reveal whether a point is a maximum or a minimum. But what happens when the test refuses to work? Yes, there are moments when this test completely breaks down. And today, we'll explore those limitations together. Let's look at the function f of x equals to x to the power 4. We first calculate the critical point by putting f dash of x equals to 0. We get x equals to 0 as our critical point. And now, if calculate second derivative value at this point, it comes out to be 0. But if we look at the graph of the function, we can clearly see that at x equals to 0, the function is a global minima. So, we can say that for given function, the second derivative test is inconclusive. Now, let's consider another function, f of x equals to x cubed. If we use the second derivative test to find the extrema, then as per test result, at critical point, x equals to 0, the double derivative also comes out to be 0. That is, it can't be determined. But if we look at the plot of the function, it is clearly visible that the function is neither minima or maxima at that point. Here, x equal to 0 is a saddle point, meaning that the graph levels off at that point. In this case, it increases, levels off, then increases again. There are some cases when the second derivative does exist, it just can't capture the whole story. For example, functions like x cubed times sine 1 over x. It has one critical point at x equals to 0, but the functions oscillate so wildly near 0 that the second derivative test becomes unreliable. Here, the graph misbehaves and the test struggles to keep up. The second derivative test has one very important requirement. The function needs to be smooth and differentiable. But what about functions with sharp corners or cusps? At these points, the derivative itself might not exist, which means the second derivative definitely doesn't exist. At this sharp corner, what's the slope? It's -1 from the left and +1 from the right. It's not a single value, so the derivative doesn't exist. The second derivative test can't help us. So, in conclusion from all of the previously viewed examples, it is clear that, while the second derivative test is a powerful shortcut, it has some major blind spots. It is a powerful tool for sorting critical points, but doesn't do all of the work to determine whether they are global extrema or saddle points. That's why mathematicians mostly rely on other tools, like the first derivative test, to settle the cases. In the next video, we'll explore some exciting rules for finding derivatives of all kinds of functions. Stay curious, and I'll see you there. Until then, goodbye. And hey, don't forget to like, share, and subscribe so you don't miss it.